Hi students, welcome to Chemistry online classes. Today I am discussing about the first year topic, that is organic chemistry, the basic principle and techniques for competitive exam. CET, NEET, JEE, everything low level to high level I will complete every concepts. So now the first chapter is very important for organic chemistry for first year to second year. Already you are learning the second year concepts. In that the main part, nomenclature and some electronic effects, that is called inductive effect, resonance effect, hyperconjugation, and some reactions are there. Reactions are which one? Substitution reaction, addition reaction, elimination reaction. But in PUC first year, maybe little bit easier addition reaction because alkene undergo addition reaction. And there is a rare substitution reaction, that is you studied in the first year main chapter electrophilic substitution reaction. But maximum substitution reaction, elimination reaction you are studying in the second year, that is haloalkane chapter. In the SN1, SN2 reaction is there, even E2 reaction also is there. There only maximum discussion is there. Here a little bit introduction also I will give. After that, how to identify which element is present in the organic molecule. If oxygen present or carbon, hydrogen, nitrogen, sulfur, halogen present. How much present? That is called qualitative and quantitative analysis. Qualitative means what is it? What is the quality? It means which element present in the compound. That is called qualitative analysis. We know that which element present. After that, how much it is present. That is called quantitative analysis. Qualitative, quantitative. So both we have to discuss because these are important for competitive exam. Their molecular formula or how to calculate if any problems is given, any shortcuts are there, that all I will discuss in this chapter. So now I will start from the basic to higher level also. Now consider this organic chemistry started nearly around 1780, very long back. Now 2020 is there. Yes, sir? So 2020. Nearly how many years are completed? Around more than 200 years are completed. Subtract 2020 minus 1780, nearly 240 nearly. So that many years are completed to develop this organic chemistry. Again, still going on this. So these years will not ask in any competitive exam. Just I am giving introduction. So you may think that how you have to remember this. No, nothing. So before that, this development of organic chemistry, in every living system we have the organic molecule, that may be plant or animal. In the plants or animals we have some organic molecule, carbohydrates, proteins, amino acids and DNA, RNA, all these are organic molecules only. These are already exist in the nature. So to form any organic compound, a vital force, somebody called vital, that is not vital, vital force you have to pronounce. You know that in biology, vital force is required, like a statement given by the scientist name, that is called Berzelius. He is a scientist. Or it is called vital force theory also. This they may ask in the competitive exam or CET level exam. Who is proposed that vital force theory or the vital force word introduced by scientist name Berzelius. Okay, you have to remember this scientist name and this vital force. Vital force meaning what is it? A special force, some which is not, we can't see that type of force is required to form the organic compound or for any reaction. He is proposing this concept, but later theories or break down that concept. What is it? In 1828, nearly 1828, the scientist's name is known as Wohler. Sometimes spelling also important for this. Yeah, sometimes they make you like this also. Pronounce now. Same way. Like this. Then one small change is there also we may not identify. Why I am telling this mean? One time I wrote in Navodaya that lecture post purpose I got one exam. In that we know that DNA, who is identified as Watson and Crick. You know that DNA model, helix model. In that every option is there Watson and Crick. Every option. But before some F something is there, that is only changed. I know what's in it, but the remaining initial I don't know that. Then totally I lost marks. Because sometimes like this possible. Very rare question may ask. But if asked, then you will lose the marks. The purpose I am telling here, this is wrong, this is right. Rare cases, sometime like this may be possible. Okay. So he introduced that ammonium cyanate. Ammonium cyanate. Ammonium cyanate. This is an inorganic molecule. Which one this is? Inorganic. Don't write in space organic. Again it is changed. Inorganic should be one word only. Inorganic, that is organic chemistry again. So carefully write. This is organic compound on heating. One side only this is. Then it is converted into which one? The well-known compound urea. See here, how many nitrogens are present? Two nitrogens are present. How many hydrogen? 4. 2 plus 2, 4. One carbon, one oxygen. Now, everyone know this reaction. You may be studying the first year also, or it may be before the 10th class, 9th class, somewhere you may be heard this sentence maybe. Now, this may be changed to competitive exam purpose. This reaction is which type of reaction? Addition reaction, substitution reaction, elimination reaction, rearrangement reaction. See, if we know this concept, then how they will convert into competitive? Then which type of reaction this is? Rearrangement. Because whatever is there, that is only present here. Then it is called rearrangement reaction. Their positions are changed. Okay, so this rearrangement. What does this reaction is? Rearrangement reaction. Then, what is the first organic compound synthesized in laboratory? Urea. What is the first organic compound if they ask? Don't answer the urea. What is the first organic compound? Don't answer the urea. What is the first organic compound synthesized in the laboratory? That is urea. Got the point? First organic compound, no one knows because it exists in the nature. Which is first form, we don't know. See, when you read the sentence, if you not read carefully, then answer changes. What is the first organic component? We don't know. That may be protein, or that may be DNA, that may be RNA, or whatever, we don't know. But what is the first organic compound synthesized in the laboratory by using this inorganic compound? That is, read the sentence very carefully, then only we will answer correct answer. Otherwise it was wrong. Okay. Later, in 1845, that is scientist name. Two scientists named for the one 1856. Kolbe scientist name. Kolbe. He synthesized the acetic acid. What is the name of this compound? Acetic acid. Well known because now already earlier treatment chapters is going on in that you may have heard this acid only there. In 1856, another scientist named Bartlett is the scientist name. He will be there. And he prepared the methane from inorganic constituents. This is also organic compound, this is also organic, this is also organic. All these are prepared from which one? Inorganic sources or inorganic constituents. These names you have to remember which side, which year also you have to remember. There is a possibility to ask year also. But rare question to ask the year, but this acetic acid, discovered scientist name or isolated scientist name is what is it? Kolbe methane battery. You have to remember the scientist name and this molecular formula also, name also you have to remember. What this name you know, that is methane. This name you know that is acetic acid. Now you know that organic compound and inorganic compound. What is the difference in the how to identify organic compound, inorganic compound? This is you know that organic, this is you know the inorganic. How you are defining this is organic, this is inorganic. Now the question is, see, we studied first year and second year. Again the same question like this asked. Then you have to decide that which is organic, which is inorganic. Now I am giving the question. Competitive exam. These are all concerned. Whatever I am giving the question, this is not related to any of your PhD. All are competitive part. So now the question is identify which is organic or inorganic. Compound. I am not writing compound just because if I write the sentence it is time taking word. Just shortcut sentences are all. Now consider this is carbon disulfide. 1, 2, carbon monoxide, 3, carbon dioxide, next 4, carbonate, next 5, bicarbonate, next 6, sodium cyanide, next 7, HCl, next 8, CH3OH, 9, CCl4, 10, COCl2, like this may be given. Then identify which is organic, which is inorganic. Otherwise, nowadays JEE exam they are asking the integer type question. Then like this they will give in that how many are organic compound. Just one number you have to write. Example, you maybe observe the question paper. Just go through that because if you don't observe the previous year question paper, you don't know what is the model present in the question paper. Each one you have to observe. If you are going for Neet question paper nearly past 10 years question paper you have to observe. If JEE means that also you have to observe. Now JEE means question paper pattern change between from last year only that is. Okay, that question paper you have to observe, but only one paper if you observe, you will not get the how the questions will come. Past 10 years question paper you have to observe. Then you can download in your mobile or directly you can purchase any one book. Past 10 years question paper book, maybe some publication Arihant or something, maybe is there. So anyone best, all are same only. Only answer solving pattern is different, but answer will be same only. So anyone you can purchase and observe the question. Then you will know that level of question, how they are asking. Now this is not that much level. Just I am going from lowest to highest now. This is considered CET level. Then this is organic or inorganic? Confusion started. Which one? Tell. Organic. Inorganic. If not, organic. Organic or inorganic. So how to identify now? See carefully observe. Carbon and hydrogen both are present, that is called hydrocarbon. Carbon, hydrogen along with its any heteroatom. What are the heteroatoms generally you observe in the organic chemistry from first year to second year? Already you are in second year, you may be observe the halogen, you may be observe the oxygen. Next sulfur also you observe ether, thioethers like this. Next nitrogen amines is there. Next phosphorus also sometime, but you will not observe because phosphorus when you will observe in the DNA. What is that? Phosphodiester bond also is there in that. You may be studying the first year biology. Phosphodiester bond also is there. So like this some are elements present. So carbon hydrogens are present, that is called hydrocarbon. And if any other elements is present, that is called hydrocarbon derivative. But this is considered as inorganic compound. Carbon disulfide is an inorganic compound, not organic compound. Okay. Carbon monoxide also you may be studying in the first year. 14th group element carbon compounds. Yes, carbon monoxide, carbon dioxide is inorganic compound. Carbonate also inorganic compound. Bicarbonate is inorganic compound. You may be studied in the qualitative analysis also. That is called salt analysis also. Yes, sir. to identify the carbonate reaction is there effervescence of CO2 will be comes out. Next, sodium cyanide. This is also inorganic compound. There is no some set of rules to identify this organic inorganic. That's why you have to practice some compounds. And when you are no need that much practice also, when you are going to read organic inorganic compound, it will be easily identified also. It is by reading only you will get this one. This for it. This one, all these are inorganic compound. All these are inorganic compound. From here to here, all these are organic compound. Hydrogen cyanide. This is called organic compound. Carbon is a hydrogen, nitrogen. Cyanide, isocyanate chapter also before is there, now it is removed. Up to carboxylic acid amine is there now in your textbook. Isocyanate is also one chapter is there. Now this alcohol, methyl alcohol. This is carbon tetrachloride. This is also organic chemistry, organic compound. This is COCl. This is called posazine. This is also organic compound. This is also organic compound. So by practicing, because when you are reading first year to second year chapter, some compounds you will read in the organic chemistry, some compound you will read in the inorganic chemistry. Automatically in your mind they are set. But it is by practice only. So try to remember like these compounds, which is organic, which is inorganic. Next, after this, what is the main important point to discuss the organic chemistry? The main role played in the organic chemistry is the carbon. Why it is carbon compounds are majority compared with the inorganic compounds? Because carbon valency how much? Carbon valency 4. And it also form catenation. What is the catenation? Same element form itself a bond and it may be converted to chain also or ring also. Therefore, due to this catenation also it forms a large number of compounds. Another one, its electronegativity not very high. Its electronegativity En is nearly 2.5, not very high, not very low. It is moderate. And compared with the hydrogen, hydrogen electronegativity is 2.1. These are having near electronegativity difference. Then they form covalent bond. Then you may be known in the periodic table chapter also and also chemical bonding also. So what is a covalent bond? If electronegativity difference more or less or moderate, then how to decide this covalent bond? So that also will give here. Electronegativity difference is 3 are there. 1, 2 and 3. Electronegativity difference. One is electronegativity difference greater than 1.7. Another is 0.5 to 1.7. This is electronegativity difference less than 0.5. If less than 0.5 is there, that is called covalent bond. Which bond that is? Covalent bond. In between this is there, that is also covalent, but polar covalent. This is greater than this one, that is ionic bond. This is important to decide which type of bond. Because here we have dipole moment also. To decide the dipole moment, polar covalent bond, if you know, then you can easily say, not exact value, at least approximately this is some dipole moment having or less than 0, like this we can decide. Now, carbon tetrachloride is there. Carbon tetrachloride. Cl, 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 Cl. Carbon valence is 4. Then 4 is there. Halogen generally form 1 bond. So 1 bond is there. Now, based on this, you decide that each bond is which type of bond. Otherwise, I will give this one also. C, H, 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 O, H. Decide each type of bond belongs to which type? Covalent, polar covalent or ionic. How to decide? Different delta E means what is the difference in electron? So I wrote E only. En, electronegativity. En that is. Difference in electronegativity. Then you maybe know that What is the here? Barium, boron, carbon, nitrogen, oxygen, fluorine. Next, beryllium below, what is that? Magnesium, boron, aluminium. This is carbon, silicon. Next, nitrogen here, phosphorus. Then these are sulfur, halogen here, chlorine. So these are very rarely involved. These are rarely involved in our organic. Involvement is there, but rare. So we know that highest electronegativity is, that is fluorine, according to Pauling scale. So many other scales are there to decide the electronegativity, like Mulligan scale or Lochel or some other scale is there. So many scales are in that. One preferable is in olden days. Now maybe other is there, but olden days preferable scale is Pauling scale to decide the electronegativity. 0.5 decrease, then here 3.5, then here 3, then here 2.5, then here 2, then here 1.5. But hydrogen comes in between. This is hydrogen how much? 2.1. Electronegative order, not according to periodic table, I wrote hydrogen. Electronegative order. Periodic table also beryllium, boron, carbon, nitrogen, oxygen, fluorine. Neon, they are already octet satisfied. That's why we are not discussing about the octet of that. Then chlorine also. Chlorine here 4 is here nearly 3, bromine nearly 2.8, like this is added very less. Now I don't want to tell remember these values. If you see one or two times, automatically fix in your mind. What is to remember? This one. And at least this one remember. Because if you remember this one, 0.5 degree back. Enough. There is no need to remember. At least one you have to remember. And chlorine compulsory. Because these are involvement more in the organic chemistry. Carbon, chlorine. Carbon 2.5, chlorine 3. Difference 0.5. 0.5 is there in what you call? Covalent bond. Equal or less than that, you consider the covalent bond. Now, here, oxygen is there, hydrogen is there. Which type of bond this is? Oxygen is 3.5, hydrogen how much? 2.5. Difference 1.5. Whatever that is greater than this is there how much? Even in this category. In this category coming is polar covalent bond. I will get PCB, polar covalent bond. This is difference how much there? 1. 1 means it comes in this category. Again it is which one? Polar covalent bond. Now carbon hydrogen, simple covalent. Because how much difference is it? Very small difference. 0.4. Okay. Then it is for just covalent bond. All these are covalent bonds. So based on this, we can easily try to decide the dipole moment. I am not discussing dipole moment here. Not much important. You just go through in the covalent chemical bonding chapter. But if you know, then it is easy to decide the dipole moment also. Because dipole moment, nothing but what is it? Polar nature only there also. Okay. Then what is the formula for dipole moment? Q into L R also is there. R means that radius we are considering. This is charge. This is the length. Okay. Otherwise, according to your physics also, that resultant dipole moment is equal under root of mu1 plus something formula is there, plus mu2 mu1 plus mu2 square I think there is mu1 square plus mu2 square plus 2 into mu1 into mu2 plus cos theta. Remember this one? Not remember. This is physics actually. We have to apply here also. That you learn in the chemical bonding chapter. Not here. So not required here to calculate. But if necessary that time, then you can just recall it. Just the purpose only I am using this formula here. Then just go through the chemical bonding chapter, whatever formula is there, you just note down here. Okay. Now, so we know that which type of bond is present in the carbon. Carbon can form which type of bond? Generally covalent bond. All these electronegativity observed with the halogen also, sulfur also, phosphorus also, their electronegativity difference are very in this one. But now consider this one, carbon and lithium. Carbon, otherwise you can say this one also, sodium chloride. See, electronegativity how much? 2.5. Then lithium, here not right? Here beryllium, which element is there? Here lithium, here sodium. Sodium 0.9 means it may be nearly 1 something, 100 for example. Not 1.1 or 1 point something is there. 0.5 is 1 only, no? 1. So difference now calculate 2.5 minus 1. 1.5 comes in this category. Then which one this is? Polar covalent. But sometimes this can be represented as like this also. Like this represented meaning what is that? Plus minus represented meaning what is called that? Ionic bond. Then based on that now we got the confusion. Yes? So that confusion is here. There is no clear cut dividing the covalent and ionic bond. Because no bond is 100% covalent, no bond is 100% ionic. Got the point? So why this can be written like this also, this can be written like this also? Because of there is no 100% covalent bond, there is no 100% ionic bond. But you may be learning the first year which one S block element, top to bottom size increases, they form ionic compound, the top element form covalent bond. So it can form covalent, but sodium cannot form the covalent bond. But we cannot now here sodium is positive charge and Cl is a negative charge. You can decide here 3 and here 0.9. 3 minus 0.9. It may comes difference in this one greater than this. Okay? So when it is there, then what you are considering? Ionic bond. But it is 100% ionic? No. It will be some covalent character also. But majority which is there, ionic, little bit covalent also is there. Okay? So that majority what we are considering now. Now, carbon valency, well known, that is 4. Don't forget this because based on that only everything is involved. Carbon valency 4. Carbon valency, don't forget that is 4. This carbon valency 4 given by scientist name Van Hoff and Level. These are the scientists, they introduced the carbon valency 4. Carbon valency 4 like this, who is given? Van Hoff and Level. Okay. Now, how to know this is carbon valency? Carbon atomic number is what is that? 6, 1s2, 2s2, 2p2. Then what is the outermost orbit? Second orbit. Here how many electrons are there? 2 electrons. Here how many electrons are there? Actually p having 3 subshell. P is a subshell. In that orbital px, py, pz. How many electrons are there? According to school we have to follow, each one should be first a singly active, then only pairing. Don't pair here. If you pair like this only, that is wrong. So here, how many unpaired electrons are present here? 2 unpaired electrons. Generally, unpaired electron form the covalent bond. But 2 mean 2 bonds only. But we have 4 bonds here. Then how to decide this carbon valency 4? This one electron will jump to here. Then that is called excited state. Then here 2s and here 2p having 1 electron. Then total how many electrons? 4. Then how this electron jump into this p orbital when you are giving energy? This energy comes from where? We are not giving always something amount of energy. Because if you are doing some reaction, you are adding some amount of one compound, you are adding some amount of other compound. Just you are adding and you may be sometimes heating. But sometimes you just add also reaction may occur. If you add also sometimes reaction may occur. Take the sodium metal, add into the water, it is explosive. Exothermia. Nothing we did, but reaction occur. Sometimes whatever the available temperature is there, energy, when you are mixing, that energy is sufficient to jump this electron to this pr. No need to provide some extra. In the reaction mixture, whatever available energy is there, that is enough to jump into this. Then it comes into this 4 unpaired electrons. That 4 unpaired electrons form the 4 bond. Therefore, carbon valency always 4. When you are drawing any structure of the carbon, always keep in mind that should satisfy the carbon valency. Now we know the carbon valency. This is 4. Yes. Now this can be written as like this also. Then this is double bonded compound, this is single bonded compound. It means it is alkane type, this is alkene type. This can be